Consider a solid body. Solid body means what, pa? Having plenty of free electrons bounded with each other, tightly packed, okay, like that. Like this, it is having some trillions of free atoms, okay. And I am considering only one atom, pa. What is the central part of atom? Nucleus. And what are all the further subdivision? It is having proton and neutron. And what about electrons, pa? It is revolving around the nucleus. And what is the charge of proton? Positive. What is the charge of neutron? Huh? Nil. Neutral. And what about electron charge? Negative. And electricity, coming to electricity, electricity means flow of electrons. Electrons are the one and only responsible for electricity, not proton, not neutron, okay. Flow of electrons. That's why now I am considering only electrons. Out of these plenty of atoms here, I am considering only electrons. Now I am considering only electrons. Like that, it is having plenty of electrons. Okay. Before I am entering into this classroom, you will be oriented randomly. Someone is chit chatting, someone is playing games, someone is sleeping. You are randomly oriented. But as soon as I enter the classroom, are you still doing the same? Are you oriented towards me or not? Like that, before applying potential, these electrons are randomly moving within the boundary. 360 degree, any direction it will move before applying the potential. So as soon as we enter the potential, potential means giving a battery, okay. Like that I am giving one. Large bar indicates positive and small bar indicates negative. Okay, as soon as I enter this potential, actually what is happening in the universe, opposite poles are attracting each other, you know, same poles are reflecting each other. So I have connected positive here. And what about this minus, pa? All negative charges are oriented toward this direction or not, pa? As soon as I enter potential, all electrons are oriented towards this positive side. Then what is the flow of electrons? What is the direction? Towards positive or not? This is current. Current means what? Charge per time, simply. The charge is coulombs, time is seconds. Or simply you are denoting by the name of the scientist, ampere. Ampere, A, okay. And coming to sign, electrons are having negative sign. So what is the sign here? Negative. What is this sign for time? It is starting from 0 only or not? What is the overall sign? Negative. So whenever you are mentioning current, you have to mention this negative sign. To avoid that, what actually we are practicing conventionally, we are assuming the current direction is opposite to the flow of electrons. This means this is I means this is I dash. I am assuming. Is there any problem? From here you are going to your native. From native you are coming here. Is there any distance difference? Is there any difference in distance? No. Irrespective of direction, distance same. Like that, irrespective of direction, magnitude remains same. I am assuming. Now can you eliminate the negative sign? To eliminate the negative sign only, we are using conventional current direction. I dash is conventional. So conventionally, we are assuming current direction opposite to the original force. Why I am mentioning this initially? Hereafter, all our problems, we will solve all problems using conventional current direction only. There is no confusion. Okay? Simple. Okay. Coming to voltage. Work done per charge. Work done means joules. Charge means coulombs. And simply denoted by name of the scientist, volts. Volts. Power means what, ba? Product of voltage into current. Considering direct current alone, DC alone, we will see AC later. Okay. Power equal to voltage into current. We have discussed current and voltage. Okay. As I already mentioned, in any circuit, there are two types of powers, delivering power and absorbing power. In any circuit, how we will calculate delivering power equal to absorbing power? We have to calculate like this, or we will generate equations like that. Okay. What is delivering power and what is absorbing? How to identify? Absorbing power, delivering power. Absorbing, delivering. Power is the product of voltage and current. If you are mentioning voltage, you should mention polarity. Wherever you are mentioning voltage, it should have polarity. Otherwise, it is meaningless. If you are mentioning current, you have to mention the direction. Otherwise, it is meaningless. So, power is the product of voltage and current. So, you are now going to classify delivering power and absorbing power. Two ends always having polarity, whether it is load or source. Load or source will have two ends. In battery, you would have seen positive and negative. Even in your loads, tube light, fan, anything you see, there will be two wires. Okay. Even in your projector also, if you see, ஸோ இதில் பார்த்தீங்கன்னா இந்த ரெண்டு எண்ட் இருக்கு இல்லையா, அதுதான் பவர். இது வந்து எர்த்து. தேர்டு பெரிய பின் இருக்கு இல்லையா, அது வந்து எர்த்து. ஸோ எனி லோடு வில் ஹாவ் டூ பின்ஸ், எனி சோர்ஸ் வில் ஹாவ் டூ பின்ஸ், டூ எண்ட்ஸ். திஸ் இஸ் சோர்ஸ், திஸ் இஸ் லோடு. ஜென்ரலி we will specify load as like this. Every load will have some resistance. So in general, across these 2 points there will be voltage, there will be voltage. Here also there will be voltage, here also there will be voltage, because this this is giving power supply voltage and this is possessing voltage. Okay. So positive and negative I have mentioned. Absorbing power means current will enter at positive. Current will enter at positive. If current is entering at positive, where it will leave? negative. So leaving at a negative or entering at a positive means this is absorbing power. Power means product of voltage into current. I have specified the polarity for the voltage, I have specified the current also, current direction also. And delivering power means what? Current will enter at negative, leaving at a positive. Simple understanding. This I am giving in terms of conventional current direction. See, here also I have taken I dash where current is entering for negative and leaving at positive, delivering power. Okay, can you understand? Can you correlate? So this is the fundamental classification. If you know this, you can solve any big problem. Okay, current, voltage, power. Power la rendu classification, delivering power, absorbing power. And coming to Ohm's law. At constant temperature, this word is important. Electric current density J is directly proportional to electric field intensity E. This means J is directly proportional to E. Current density means what? Current per unit area. The proportionality constant is conductivity, sigma. And the electric field intensity means voltage per unit length. You would have studied in school level, right? Can you remember? Okay. J is equal to sigma E. This is called first form of Ohm's law. This is called first form of Ohm's law. From here we are going to derive V by I. Now V by I means I you have to bring here, L divided by sigma A, V equal to, you are mentioning this as resistance R I. This is second form of Ohm's law. Actually we are going to use this formula. Now if you are drawing like a graph, see it resembles like y equal to mx or not? Y equal to mx means what? A straight line passing through origin. So in y axis you are having J, in x axis you are having E, and sigma is a constant line or straight line passing through origin. And you can apply the same to second form also. Y axis you are having V, x axis you are having I. Resistance is a straight line passing through origin. Okay, this is Ohm's law. And from here you can get individual parameters like V equal to Ri, I equal to V by R equal to V by I, power equal to Vi, you know. For V, if you are substituting Ri, you replace this V with Ri. what you will get? RII means I square R, another formula for power. And if you are replacing this I with V by R, you will have another formula. These are all the fundamental formulas you should know to solve the basic problems. And we will go for Kirchhoff's voltage law. இப்போ கவனிங்க, எலமெண்ட்ஸு நம்மளுக்கு வந்து சோர்சர்ஸு அண்ட் அப்சார்பர்ஸ் ரெண்டு தான் இருக்குது இல்லையா டோட்டலாக. இப்போ இந்த சர்க்யூட்டை பாருங்கள், இது சோர்ஸு, இது மூணு அப்சார்ப் பண்ணுது, அவ்வளோதான். இது டெலிவரிங் பவர், இது அப்சார்பிங் பவர். டெலிவரிங் பவர் இஸ் ஈக்குவல் டு அப்சார்பிங் பவர், அவ்வளோதான். கிர்ச்சாஃப்ஸ் வோல்டேஜில் என்ன சொல்லுது? இன் ஏ க்ளோஸ் டு லூப் சம் ஆஃப் பொட்டன்ஷியல்ஸ் இஸ் ஈக்குவல் டு 0. இன் ஏ க்ளோஸ் டு லூப், in a closed loop sum of potential equal to 0. இது ஒரு ஸ்டேட்மெண்ட். ஆல்டர்னேட்டிவ் ஸ்டேட்மெண்ட் என்னன்னா, பொட்டன்ஷியல் டிராப் இஸ் ஈக்குவல் டு பொட்டன்ஷியல் ரைஸ், இஸ் ஈக்குவல் டு பொட்டன்ஷியல் ரைஸ். அடுத்தது கனெக்ஷன் எப்படி தெரியுமாப்பா? இது ஒரு காம்பனண்ட். எவ்ரி காம்பனண்ட் வில் ஹேவ் 2 ends சொன்னேன் இல்லையா? இது ஒரு காம்பனண்ட், இது ஒரு காம்பனண்ட். சீரியஸ் கனெக்ஷன் என்னன்னா, இங்க பாருங்க, ஒரு எண்டு, இந்த எண்டு, இது ரெண்டுத்துக்கு நடுவில் ஈக்குவலன்ட் ரெசிஸ்டன்ஸ் பார்க்குறீங்க. இன் பிட்வீனில் இது இப்படி ஜாயின் பண்ணுறீங்க. இப்படி இருந்தால் அதனால் சீரியஸ் கனெக்ஷன். எப்பயுமே ஈக்குவலன்ட் ரெசிஸ்டன்ஸ் ஆர் எஃபெக்டிவ் ரெசிஸ்டன்ஸ் யூ வில் சி இன் 2 points ஒன்லி. அந்த 2 point எப்படி இருக்கும்? இண்டிவிஜுவல் எலமெண்ட்ஸை ஒரு எண்டு கூட கனெக்ட் பண்ணிட்டே போகிறீங்க, கடைசி இருக்கிற ரெண்டை இப்படி ஜாயின் பண்ணிங்கன்னா அது ஆர் ஈக்குவலண்ட் வந்து சீரியஸ் கனெக்ஷன் அப்படின்னு சொல்லணும். அப்போ ஆர் ஈக்குவலண்ட் இங்கே என்னென்னா R1 + R2 + R3. கம்மிங் டு பேரலல் கனெக்ஷன், அதே ரெசிஸ்டன்ஸு எண்டு டு எண்டு ஜாயின் பண்ணணும். ஒவ்வொரு எண்டையும் ஒவ்வொரு எண்டு கூட டைரெக்டாக ஜாயின் பண்ணணும். இங்கே பாருங்கள், இது ஒரு எண்டு, இது ஒரு எண்டா, இந்த எண்டு இந்த எண்டு டைரெக்டாக ஜாயின் பண்ணிடுறேன். இந்த எண்டு டைரெக்டாக ஜாயின் பண்ணிடுறேன். இந்த எண்டு டைரெக்டாக ஜாயிண்ட் அண்ட் யூ ஆர் சீயிங் ஈக்குவல் ரெசிஸ்டன்ஸ் அட் ஹியர். இப்படி இருந்ததுன்னா பேரலல். பேரலல் மீன்ஸ் போத் ends should be joined with another both ends. இதுக்கு பேர் பேரலல் கனெக்ஷன். இங்கே ஈக்குவலன்ட் ரெசிஸ்டன்ஸுக்கான ஃபார்முலா என்னென்னா, ரெசிப்ரோக்கல் ஆஃப் ஈக்குவல் ரெசிஸ்டன்ஸ் தான் யூ வில் கெட் 1/R1 + 1/R2 + 1/R3. ஸோ இது ரெண்டு யூ ஷுட் நாட் ஃபர்கெட். அப்போ கம்மிங் டு திஸ் சர்க்யூட், இஸ் ஆல் தி ரெசிஸ்டன்ஸ் கனெக்டட் இன் சீரியஸ் ஆர் பேரலல்ப்பா? சீரியஸ். ஓகே, இன் சீரியஸ் there will be only one path. அதாவது இங்கே பாருங்கள், இது ஹை பொட்டன்ஷியல், இது லோ பொட்டன்ஷியல். எலக்ட்ரான்ஸ் நம்ம கன்வென்ஷனல் கரண்ட் டைரக்ஷன் படி எலக்ட்ரான்ஸ், திஸ் இஸ் டெலிவரிங் பவர் ஆர் அப்சார்பிங் பவர். பேட்டரிங்கிறது டெலிவரிங் பவர். டெலிவரிங் பவரில் கரண்ட் எங்கே என்ட்ரி ஆகும், எங்கே லீவ் ஆகும்? இப்போ அப்சார்பிங் பவர் டெலிவரிங் பவர் போட்டேன், அதுபடி சொல்லுங்கள். நெகட்டிவில் என்ட்ரு ஆகிட்டு பாசிட்டிவில் வெளியே வரும். அப்போ இதுதான் கரண்ட் டைரக்ஷன். Throughout the circuit, this is the direction. Voltage means it should have polarity. Current means it should have direction. Otherwise, it is meaningless. Okay? Can you identify? Okay. Now, you know this is delivering power. You know this is absorbing power. And what is the polarity of absorbing power? Pa? In absorbing power, where the current will enter? Positive enter, leaving negative. So in between these 30 ohm there will be a potential and current is entering here. This is absorbing power. So polarity of this voltage is positive minus. Any doubt? This is the voltage across 30 ohm. And coming to 50 ohm, these are all the 2 ends. In every two end there will be a potential. Current is entering here, leaving there. And what is the polarity of this voltage? This is the polarity of voltage. Coming to 100 ohms. 100 ohms also acquire some potential. What is the polarity of that potential? Current is entering here, there. So here positive, here negative. Okay. So all the resistance are connected in series or not? So what is the equivalent resistance? 30 plus 50 plus 100. How much? 180. 180 ohms. And current in series circuit, see, there is only one path to starting point to ending point. There is only one path. If there is only one path, there is only one current. If more than one path is existing to positive negative, then current will split. Simple. In series circuit, current is same, voltage differs across the elements. Across the elements, current is same in series circuit, voltage is differs, because to start from positive to negative there is only one path, so there is only one current. So current is same in series circuit. Coming to parallel circuit, if I am applying some potential here, if I am applying some potential here, what is the direction of this current? Delivering power, what is the direction? Positive. Simple. And what about this? This is absorbing or delivering? So it will buy, it will get. So this is the direction. It will get. So this current is splitted into three individual currents, because this current will again move to negative. There is a path. And what about this I2? This I2 also having a path to return. And this I3 also having path to return to negative side. So in parallel circuit, voltage remains the same between these points, because these 2 points are same. There is no component here. These 2 points are same, these 2 points are same. Completely there is a single wire is connecting, so these all points are same. These all points are same. So here also same potential is appearing. If here, this is 100 volt, here also the same 100 volt will appear. Here also 100 volt will appear. Here also 100 volt. Current will be different. So in parallel circuit, voltage remains the same, current differs. It's the very fundamental thing. Okay, you should not forget. Now you consolidate. I equal to V by R equivalent. Total current I am, because only one current, that is IA. I equal to V by R equivalent. V is 100 volt. 100 divided by 180. You tell the answer in calculator. 100 by 180 எவ்வளோப்பா? 0.55 55 ampere. This is the current. And coming to individual voltages, I am now calculating voltage across 30 ohm. V 30 ohm. V 30 ohm is equal to, V equal to what formula? I R. I you have found. I R is individual resistance. I am finding the voltage across individual resistance. I R means you have to substitute 0.55 into individual resistance, because you are finding what is the value ma 0.5 evlo 16 but you calculate and tell me, otherwise answer will differ. And what about V50? 0.55 into 50 V100 0.55 into 100 இது நம்ம எவ்வளோ 16.5 volt. What about this? 27.5 volt. What about this? 55. That's all. Okay. So these are all the voltages available at the individual resistances. 16.5 volt, 27.5 volt, 55 volt. Now you can start from anywhere. I am starting from here. I am starting from here. What potential I am seeing initially, I am writing. Here what potential I am seeing ba? Minus. What is the value of the potential ba? 100. And I am traveling. Coming here, here also there is a potential. What is the polarity ba? Positive. What is the voltage? Coming here, I am seeing positive sign and the voltage is 27.5. Coming here, I am seeing positive sign and the voltage is 55. Equal to sum of potential is equal to 0 according to Kirchhoff's voltage law, equal to 0. Now, either you can bring to RHS or you can bring all three values into RHS. You add these three, how much? How much ba? 99.9. 99. So 99 positive negative sign that go. Actually, if you are adding another decimals, then you will get almost 99 means 100 it will come. So this equation gives this statement ba. In a closed loop, sum of potential is equal to 0. Potential drop is equal to potential rise. This is potential rise. These are all potential drops. Can you understand Kirchhoff's voltage law now? Okay.